So I'm going to go over the lab. So we have an idea where we are going, and then I'm going to go back and basically say what you need to do, and then we're going to go back and go over individual pieces that you need to know to get the assignment done. So the first one is we're going to work with a path runner script. I've told you in the description of the lab, I'm asking you to not rather than use path runner script, use list runner instead, so that there's a much difference. This is so that we can separate what you did. Yeah, the previous script and this script would be easier if you just go with list runner. So you're going to use a list. You're going to remove target A, target B, moving A variables. You're going to create a new public list of objects called path list. You'll have an integer called path list index and initialize that to 0. And then you'll basically update that script to use the list and the index as opposed to the only two. Create a path consisting at least 4 locations and use game objects to mark your pathway on the map. Basically what you've done already, just now more. Add a script to a new capsule character, assign and path points to list, and test it. So that will be the first thing that we'll do, is to create the list runner. In a new machine, you're going to create a new map called Plinko. And there is a Plinko machine that I've given to you already. We're going to basically spawn balls, discs basically, that have been given to you. And we're going to set up the machine to, record when a ball's gone into one of the slots at the bottom. We're going to start building a combat game. And so there'll be a combat script. There'll be a projectile. So we'll build a projectile prefab that will basically just move with the rigid body. And then we'll set up the combat polar script. Oh, I am giving you... Did I put them here? No, where did I put them? Thought I made a copy of the scripts. Okay. No package for some reason? No. Okay. We're going to make some changes to the combat player script. So that, and yeah, I'm going to tell you what basically I'm telling you how to map them. Yeah. We'll come back. But basically, we're going to set up some functions that we'll be using in future labs. So, like right now, we're going to get the player, we're going to get them moving around. We'll update the movement. And then we'll go to, we'll set up Fire 1, Fire 2, and a couple other functions here. So. So that's where we're going to go. All right, let's talk about containers. All right. So when you hear the word container in computer science, programming language in general, think things that are holding stuff. Right? And there's different styles of different containers. For you again, the two that you are going to use primarily in C# with Unity right now are going to be the array and list. There'll be others, but these are the two that you will use most often. Array is a fixed number of objects, and a list can be expanded. Basically, the difference between the two. To declare an array, you use the name of the type, and it's the hard brackets, and then the name. The size of an array is called its length. So array name.length will give you the number of items in the array. Do want to remind you that arrays and lists are 0 order. So the first element in the array, first element in the list will be of 0. The last element in the array is so if we use n for number of objects, then n minus 1 is the last item in the array or the last item in the list. Primitives and structures are value type arrays, so they will initialize with the default value of the type, and then objects will be initialized with null and all array locations. So if you're building an array that is of an object, so a class specifically, then there'll be nulls in the array. Again, lists are containers of variable size. You can easily add, remove, and clear them. And the size of a list is called its count. By default, a list starts with nothing in it. And to declare a list, it's list, parentheses, type, list name. Also, you do need, and I'll point this out. You do need a package called systems.generic.collections. I think to basically to use the list. So we'll go over that in when we get it closer. Again, here is an int array. Here is a game object array. Here's a list of game objects. So when you make a list, there's the angle brackets. That's what's going to determine what type of variable you're going to hold in that list. Whereas the name of the basically this is the type, and this is saying this is an array of that type. Any array list made a public member of a class is editable in the editor. So basically what that means is that when you go and make a list or array public, you can set them up as you see fit in the editor, and that will initialize them automatically. So here is int array, object array, game object list. Again, here they've gone through and they've set size here. Again, in this case, we've got no game objects in the list at the moment. And again, when it initialized it with 3, it came and initialized to 0. So again, none here. Think of it as a null reference. So there's that would. So if you ask for element right now of the game object array at 0, you'd get a none. Same thing with the game object list. If you asked at element 0, you get a 0 in that case. How do you access elements? And this is both. It's a single. This is a part of an array or a list. We use what's called array notation. So basically, container name and then the index at what you want to use. Can be a number specifically if you're going to hard code, and it's also you can use it by variable. So that's why we are, again, particularly since we're counting through a list or an array, we'll have an index that we can change. And here is accessing at elements, first object in game list, and we're using the game object.name. Now this assumes that we have an object in that element to look at. Container size, int array.length, int array object array.length, and then object list.count. So where, in the case of public arrays, public lists, Unity is going to take care of the initialization for us. When you create an array list that's declared private, that is protected, or it's local to a method, you're going to be responsible for initializing the array or the list. And again, here's list operations. Here is declare the list type, list name equal to new list type. So this is how you would initialize the add list name.add, item to add, list name.remove, item to remove. You can remove add an index. You can ask if an item is in the container. You can clear the list, and you can get again the count. Array initialization example here is int array new int 5, string array new string 6. So again, here is array values here's a, into array. So here's 6 empty strings. 1, 2, 3, 4. Yeah, 6 empty strings. So that's our first piece. So let's jump in. Let's go over. So let me collapse everything. Create new folder, lab 06. First thing is I'm going to go and grab, actually, let's go back. Let's create the, list runner script. All right, let's go back to lab 4. Let's open up the path runner. And again, grab everything. Again, what we're looking for. Why do I have Unity? All right, something I'm going to point out right now. Visual Studio has added things to my script for whatever reason, and I don't know why. I'm not actually using visual scripting. I can get rid of that. I'm actually not using the event systems. We can get rid of that. We will eventually talk about events later on and creating our own events, but for our purposes right now, we're not using them. So I'm going to grab all of these. And basically, again, I'm grabbing what's inside. This is the end brace for the path runner class. And here is the beginning. So I'm just grabbing what's inside the class. Go to list runner, and I'm just going to go in here. I'm going to paste that all in. So again, basically using, I know we're copying a lot of code, but basically we're transforming the code significantly. So I need to use using system collections dot generic, and this is where the list resides in. I will go back and update the slides to make sure this is added. Unity used to add this package to every script previously. They have not. So, all right. I'm going to start by making a public list. So public list, and it's going to be of game objects. Yeah, capital G game object, and this will be my path list. All right. Visual Studio was trying to like initialize it and all that good stuff. No, don't worry about it. Because even if you do initialize it, it was trying to initialize it here, which is, for me, I typically would not initialize a list right here. It's an object, so I don't initialize objects as a default. The other thing I'm going to make is I'm going to make it. No, I'm not going to make public. It's going to be integer, and it's going to be called path list index. I'm just going to go in and I'm going to set this to 0, and I'm just going to make sure I capitalize the L list here. So these two variables right here are going to replace all of these guys. In fact, I'm going to delete these right now. Now, doing so has caused 7 different errors. Well, that's because, again, we're setting, again, so the first one is moving the A. That's going away. But current point is going to be not point A. It's going to be my path list at 0. The other way I can do this is also path list, and I'll do this path list, and this is more common what I'll do. It's my path list index. Just to make sure path list index is equal to 0. So I'm going to start at 0, call it 0. So first 2 errors are gone. The next one is the next 5 errors that are left are in next gets target. I'm going to take all of this out. So get next target. I mean, ultimately, again, I'm going to grab the one line of code right here. Current point. I'm going to drop that down into here. I mean, that ultimately, my last line of code in this is the current point is equal to my path list index. So the first thing that we'll do is path list index increment by 1 plus plus. Now, there's more code here, but this is the first. The only thing what's going to happen here is that when I get to the end of my list, let's say I have 3 elements. It'll go, again, grab 0. When I get to the first element, it'll go to element 1, go to element 2, and then it will try and go to element 3. Because I only have, that will be outside of the range of the list. So that will cause an error. So what we just need to do is just make sure that path list index. So if is greater than or equal to the path list dot count. So I use greater than or equal to. And that's just me being, it's secure code. It is making sure that if for some reason index got tampered with for some reason, who knows why it got tampered with. But if it was tampered with for some reason and the index for some coming here is 15, there's only 10 in that object in the array. So basically, just by making sure that I am past my that it's past the end of the array as well. It's just a security blanket, basically. Paranoia is good for your soul as a programmer. So for some reason, index again got tampered with somehow. You get here, now you'll set it back to 0. Again, path list index will be equal to 0. Is that to the beginning? All right, I'm going to write another version of this function. This is going to be void get previous target. Okay. So I'm going to note here, this is extra. You don't need to write this in your assignment. All right. So I'm going to grab the body of this right here. I'm going to copy this in. So if we're going backwards in the array, then we're looking at, is it decrementing? And in this case, if it's less than 0, so basically we're gonna set this, and this is going to be essentially the count minus 1. There you go. It'll be easier to read that way. So we're going to reset to the end of the list. Again, count minus 1 is our last element in the list. So 0 is our first element. So we get to 0, we're okay. It's the -1 and anything negative we're going to deal with. I'm showing you this so that you know. This is just another pattern. You know, we are going forward. How do we go backwards? Pretty straightforward. You don't need this for your assignment this week. But at some point you'll want to, like, again, I have a list of weapons that my character's holding. Next weapon will go down that list of weapons. Previous will go the other way. So I'm just showing this so you know, so you can see the pattern. Here's forward, here's backwards. Just get to know this piece of code, because you're gonna use it over and over again. So, and that's all that we need. Again, this one has no references. Again, there's a couple references here. But that's all. I mean, we don't need to do any change anything else. Again, point A, point B, we're just game object references. We're just playing with game objects. Let's save. Let's go open scene. Let's go back to here's the left 4 scene. And here's path point A and B. I'm just going to copy and paste them. And I'll call this one C and D. And I'll grab them. Oh, I set them up weird. I'll pull this out this way. And I'll pull them up this way. Ugh. And I'll grab a copy of you. And he will be our list runner. So and I'm just for the sake of argument, I'm going to save as into my lab 6 folder. Just so that I have a different file from the previous lab. On the list runner, I'm going to just remove the path runner script so we can go and remove the component. And then we'll put the list runner in. And here's the path list. One thing that's really cool about Unity, I can lock the editor. I can then now select these so I don't lose what's in the inspector, and I can click and drag them to the path list name, to the name of the variable here, and it will populate them in order, which is a cool feature of Unity. So, where's my list runner? Let's drag him out, and let's go to make this one pink. No, I'll go orange. There we go. So we know the orange. So we know this one will go to these 2 path points respectively, but this one's going to go to the 4 path points. So I'll go press play. Again, he's going to go. Yeah. You can see right there, he's going on 4 points. Off we go. Pretty straightforward. Oh, stop. Save. All right. Under application, we have I had you create a combat folder, Plinko folder. Do the work for the game in those folders effectively. You'll have copies of. You'll use other scripts as well. Let's get back to. Let's just jump into the Plinko. So let's just file new scene. Empty. In fact, this is the case where. Yeah, we'll just do empty and create that. Go to your Plinko prototype, and there's a machine. Drag that into the world. And the machine has directional light, main camera, everything else you need. So there's nothing else. Make sure the machine is at 0, and it is. And, we'll press play, and hooray, we're good to go. So file, save as. And let's go to our application into Plinko. And we'll go set Plinko as our file name. All right. So I'm gonna bring this around. Get more room. We can fact, I'm going to just put these together for right now. All right. So I am going to create 3 boxes. Here we go. 3D object. So let me get this at 0, 0, 0. And we'll see this. So I want to be 17, about 17 high. We'll pull this back just a little bit. So I'm going to leave that box right there. So 17 up, 3 back. Click. Yeah, that'll put me in a good spot. All right, next thing I'm going to do is this is going to be my disk spawner. Now we'll come back. We're going to set it up to move back and forth for right now, and then the next thing we'll do after we've done another piece of the lecture, we'll spawn the disk. But I'm going to duplicate this. I'm going to do left path. Duplicate one more time. Right path. So it's up to you whether you use the path runner or you use the again, and I'm going to move this about here. I'm going to come in just a little bit. So that was 18 on that side. So I'm going to this will be, actually that should be negative 18. There we go. And this will be 18. All right, so we'll go to the disk spawner. I'm just going to use the path list runner because why not? Oh, undo that. Again, I'm going to lock this one moment. Grab the 2 path points, put it into the path list. So I chose to use the list for this case. You could have used the path runner. Either would be fine. Do make sure, I'm going to unlock this. For the left path, right path, make sure that you turn off the box collider. In fact, for the disk spawner, also turn off this box collider. This is so that when you spawn your objects, they're not the box. I mean, these are just here to be points in space. You'll need this one to be seen, but these guys, you can, in fact, you can take this further. You can turn off their mesh render as well because they're just marking points in space. This is marking point space, but it all needs to be visual. So if we press play, and you'll see off it goes. And I'm just going to go crank this up. I'm going to do 30 just for the heck of it. I'm just going to move that up just to be on the safe side. Let's see, 2.5. So basically that's going to be my disk spawner. So we are going to, again, let's go to the Plinko. And so what we're going to do in here, we're going to create another script. It will be the disk. And what I'm doing right now is I'm going to add another script to it. Heck. Collapse these. There we go. So I now have two. So you can have multiple scripts because scripts are components. So we're going to write. So we've got list runner doing one thing, and we got the disk spawner doing something else. So we'll write some more scripts in a moment, but let's move on. While we're here, I'm actually going to create 2 more scripts, just so that we're there's going to be the Plinko disk, and I made a material. My apologies. The other script we're going to create is the Plinko slot. So we'll come back. We're going to come back to that. I'm going to go back. So before we go on, now we need to, what's the next piece? We're going to talk about some looping structures. So for each, do and do while. The big one that you're going to use for most part is the for each. Again, for is, let me make this bigger. We want to go over there are 4 containers. For each, do, and do while. So this is a flip on the while loop, effectively. But basically, for loop is when you know the number of times you'll need to loop, so that you are going through everything in this container. If you need information related to the index variable, declare the variable before the loop. If you wanted to store the last index process, for example. And here is for initializer, conditional incrementer, code block. So like, for example, is so let's use like the object array. The example would be for, we'll just say integer index is equal to 0. The condition is as long as the index is less than the count of what we're working with. So there would be like the object array dot length, or the object list dot count, and then you'd increment it. So that'd be I plus plus. Now there are stagnated lists. There's ways that you're setting up a list, like you have an array of a list of things that can hold multiple things, and so like every 3 is values, for example, and that's something that that will come up in other languages and other scenarios. I'm just saying you can do that. There's one specific reason you would. Otherwise, you're typically incrementing by 1. For each, when you want to iterate all items in the container, so like arrays and lists, there are ways to break the for each in early, but this is rare for special cases only. The other thing is you don't want, the one thing about the for each is that you don't want to change the items in the for each loop. We'll talk about that in one moment, about if you were like going through a list and seeing what's dead to remove them from the scene. You would ideally you'd make another list. You would go through the list, put them into another list to hold, and when you're done finding them, you then go through that second list again to remove from the first list. So again, for each, type in container, element name in container name. So type in container. Now you'll see a lot of people use var. That's lazy, but it works. Element name, so what you're going to refer to. So where in the for loop, where you would have gone, the first thing you would have done is reference variable equal to my container, hard brackets, the index I'm working with. That's taken care of for you with the for each right out of the gate. So they've got examples. While loop and do whiles are used while you don't know the number of times you could loop, and it's good practice to use a Boolean to control the while loop. While has the conditional up front. The do while, you do the first block, and then you check at the end of the block. Potato, potato. Sometimes you do one, sometimes you do the other. So, the big thing about the while loop is that you have to check inside that code block whether if you're using a Boolean to control that, then you have to write that conditional statement for the Boolean inside the code block. Something you got to do every iteration. Are we continuing next? Think of it as rounds. Are we going another round in this code block? If this is one of the things, if you screw up the while loop and it goes infinite, so basically it never breaks, you will hang Unity, the editor, and then you will have to go to the task manager and force close Unity because it's got stuck in a loop. So you'll understand this. So again, I'm showing you the do while and this right now. You'll use them more in if you're writing pure C++ or pure C code. If you're not particularly Unity code. So just want to make sure you guys that. Let's do the spawn and destroy next. And then we'll talk about object-to-object stuff. So spawning and destroying. The word you want is instantiate, and you want to instantiate prefabs. All right. To spawn a new prefab, you need to know the original prefab or object to spawn, where to spawn, and the rotation to spawn. Sometimes you'll give a parent to spawn to. And let's actually go. When we get back, we'll set up that parent for the disk to spawn into to show you. We'll do it without, and then we'll do it with. So, destroy. Destroys something from the world. Can be any game. It can be a game object. Can be a component. When you use the keyword "this," you're referring to the current script you are typing in. So, destroy this just removes a script off the game object. You can use lowercase g game object and remove that game object from the world. You can also give an optional parameter to set a time for destruction. So this is time from after the destroy call is made, approximately. And we'll use that. We'll set up the disk spawner in the disk slot to destroy those disks. And they've got some scripting videos and topics. All right, concept that I want you to think about. Factories. Factories refer to classes and objects that handle creation of other objects. Term factory was heavily used by Epic in the development of Unreal Tournament. It's still there. It's less so now in Unreal Engine, but it is something that think of it as a pattern. A factory builds something else for you. So if you've got a complex game object that needs a bunch of setup, think about making a factory. Basically, it's a function that you can call, and the return basically is what the factory ultimately returns is the final object that you want a setup. Can be for object creation, can be object spawning, and then that depends on what you're used. So here's a factory example. Enemy spawners in Gauntlet 2 are a factory. Think of them as they are a little factory and every second they are like. So basically, the factory for Gauntlet 2 basically is X number of seconds spawning new enemy. Factory knows what enemy it is and knows the area around it to spawn enemies. And if you run out of space, it knows what it needs to do if it runs out of space, and so we'll leave that into. We're not going to worry about spawning in if it has room type of question at the moment, but that's a factory example. Here's Gauntlet spawning the enemies. Here are and again, they're also destroyable, so they have a health component essentially. That health, one of the things that you would do with a health, and that's one of the events systems that when we would look at events, that's one of the things we'll use. It has, when I run out of health, do this. All right, object to object communication stuff. So first one is if you make something public, if we edit in the editor, if we have a reference to a script in C#, we can access all of its public members and methods via the dop operator. So we will, when you did the soccer game, the reset function was made public so that we could call it from, the net could call it. Script names are C# object names. We can use them as a type of variable. So you use, types you use already is int float, game object, transform vector 3. Rigid body should be in that list. We use the quaternion for rotation data because we're just getting and setting it. And you've started using, and so again, particularly this week for the slot, one of the patterns we're going to use is basically we're going to ask for when something falls into the slot. First thing we're going to do is ask, is this of type of the Plinko disk? Public access. This is again public access. Here is a public int. Here's a private int, and here is code trying to use the private int, and it's going to fail. Well, I'm sorry. Here is what's going here. Sorry, my apologies. What's going here is like a public function that takes an integer and then assigns basically the private number. And again, here is show numbers. Here is void start. It creates a public access script. Here's public int. It says change public private int, and it shows the number. What you can't do is that reference to the public script and directly access the private variable, and it's not allowed. So, these diagrams are just a visual way to think of the object hierarchy of the components. So like blue is transform, the render mesh is purple, collider is green, rigid body is going to be yellow, and any script's going to be this light blue. And these are just to understand, hey, representation of things on your. And I think render mesh, and I think the mesh renderer and the I've linked together two things together under the render mesh. So here, yeah, the mesh filter and the rest renderer I've isolated, in the default material I've isolated under that purple in this case. So again, here is what a game object, like a sphere, what has its sphere collider, rigid body, has a script draw forward ray. Empty game object, again, this is just going to be the transform. These tags, so next to the game object, there's a box right here. You can click on that, and that will bring up options to basically set, basically an icon on the object, or to set a tag like this. I'll go show this in the editor when we get back to it. Capsule collider. So a version of this player one back in the day, the cube that was the visor on the player was parented to the capsule. Today you have a version of where player one and the capsule and the cube are just child of that first empty game object. But in this case, it has its visual component, has colliders, but the rigid body is up here and the script is up here. And this is why when we went in the net, we saw a capsule and cube, the visor. We saw two names because we were catching these two rigid bodies when we went in the net. Tank object, pretty straight, similar. Here's the tank, capsule, cube, sphere. Again, these are the treads. This is the main body, top of the tank, and then the cylinder is the barrel. Collision, all collision components are in the child objects. So multi-object, we raycast visualize. In this case, the rays hit the cube through the collider of the cube collider of the tank. We hit here but the script we want is up here. So the answer is transform.parent. There's get component in. There's we can look down from high object up high and look down, but you will use mostly component and parent. Both of these return a single component. So in this case, let's go back to the tank. The script here will be called combat character or combat controller. So you'll get a reference of this cube, the collider here. You'll ask collider.gameObject dot get component and parent of the combat character. Because if I just get component here, I won't see it. But that's why we'll use get component and parent. So get components in, we'll return an array of components. And then there's messages, and these are more complicated. Send message sends calls the method name on every model behavior in this game object. Broadcast message in the game object or its children, and then send message upwards. So find basically is a bunch of static objects. Finds a game object by name, returns it. Find with tag. Don't use the tag system. So there are ways you can tag objects. The problem is that you can if things are not tagged properly, then this fails. Find by type. This is what I would prefer you. So if you were looking for all of the path points, then you'd have a path point script on your path points. And then you can then look by path point and get all of those. Find type by all the players. For some reason, this script needs to know all the players in the scene. So you find, like, again, what we're going to do with combat is to be the combat controller. Back in soccer, it was the rigid body mover. So finds are by definition kind of expensive, so you don't want to be doing that every tick. Just to be forewarned. If you can cache them, add remove rather than maintain by adding removing is better than to just find by type every single frame. So all right, so let's jump back to Unity. Here's our Plinko scene. All right, let's start with the disk spawner. All right, disk spawner needs to know, and we do need to be using Unity Engine input system. And basically, I'm going to write my input code right here because it's going to be spacebar. So keyboard KB is equal to keyboard.current if KB is not equal to null. Then if KB space key was press this frame. And I'm just going to make a function called spawn disk. So I'll just write down here void spawn disk. So just to isolate that code. What do we need to know? So first of all, we do need the prefab. So this would be a public game object disk prefab. So down here, again, we can just instantiate. And we can go, hey, object original, disk prefab. Okay, so the object that you're giving it can be, so we're going to use the variable here, and it'll be a reference from our, so the prefab will be in our content folder. You don't have to. You could have put something in the scene and spawn copies of that. Just be mindful. Yeah, that's one of the things. It's just that you can spawn copies of things that are in the scene already. For our purposes, this is more akin to where we would want to be. I'm gonna go back. I'm just gonna go back and reopen this, and I'm gonna note that there are 13 different versions of instantiate. So this what we call function overloading. Here's the original parent scene, parent instantiating world space. You know, the one that you will use most likely is number 5, the original, position, and quaternion. The other one that you'll use is number 6, which is original, position, rotation, and parent. So we'll come back. We'll look at that in one moment. So let's go instantiate. Where we are spawning this, it's going to be our game object transform.position, and then not path list. There we go. And then it'll be game object transform dot. We could do not root, rotation. There we go. There's a dot, not a comma. So basically, original. Original, position, rotation. If rotation's not a matter, you could have done quaternion.identity. So, I'm just going to do, basically I'm going to do a quick if statement here. We're going to add public bool use spawn in parent public transform let's call it the spawn parent. So this is going to be basically if spawn in parent so I'm going to move this right inside. And then it'll be else. We'll copy that in this case. This would be rotation, and this will be spawn speed transform. And we'll just use the variables spawn parent. By default, I'm going to assign this to false. So we'll come back and we'll look at this is the code effectively you're going to write. Normally, you're either going to do one or the other. I'm writing it. So when you do your exercise, you're going to do one or the other. You're not going to do both of these. So if I see you do both of these, I'm going to call you out on it. Because you're writing extra code that you don't need to. I'm writing extra code to show you, to demonstrate. But it's again, you're either going to do either one of these, but not both. And I will take off points if you do that. So that's because and the reason I'm going to take off points is because you're just blatantly just copying code as I'm writing it. and not understanding what the code is doing. So, all right. So disk spawner. So you see, let's go to my Plinko assets. Yeah, I already have a disk. All right. I'm gonna bring this into the world. And I'm going to break the prefab, actually. I'm going to create a new prefab. So I'm going to go prefab. I'm going to just unpack completely. All right. And the reason I'm going to, because basically right now this is just basically a sphere with a yellow material on it. We're going to add component. Obviously, it's going to have a rigid body. I don't need to do anything in the script for the rigid body. Might make the mass. We'll make the mass 10. Make it. I don't need to touch anything else. The other thing that I need to do under applications, I'm gonna go again in my disk prefab, and here is the Plinko disk script. Does that script need to do anything else? Not really. This is the case where, I mean, we can literally go into Plinko disk and we can take everything out. This is a structural class. It doesn't. It establishes just the entity. So for, again, one of our entities in our game is the Plinko disk. Plinko disk just needs to be set up and to spawn in the world. It has the rigid body, so it's going to be a physical object. But it's not doing anything else. But we need this script because we need to reference the script as an object. As a particular object, I should say. So let's go back. Here's my disk prefab. And I'm just going to just bring that into, make a new prefab here. Now that I've established the prefab, I can delete it from the scene. All right. So let me bring this back for one moment. So the disk spawner, you can go be like, hey, the disk spawner, put the disk prefab in the scene. That's wrong. You again, yes, you are making a copy of this object, but that's not what we want. What you want is not the object in the scene. Is the disk prefab. Let me just clear this. Make this back to none. What you want is to make copies of this prefab that's in your content, your project folder. Now I'm actually going to remove this from the scene. So now I go press play. You can see. Now there is the next issue that we will need to deal with is that now as the balls are now falling, as we expect. And you can see as you make copies of this, they come as clones. And you can see that they're now starting to filling out my scene with those clones. So this is where we're going to create an empty object. Put its position at 0, 0, 0. And this is going to be the disk holder. Actually, I'll call it disk parent. Okay. So in this case, I'm going to bring this up here. So it's underneath the disk spawner. I'm going to assign that to the object here to be the transform. And we'll click spawn in parent. And now this case, no, the only thing that's changed is here are all so I can collapse that now. So if So this is basically making my life easier by putting them into the air. Problem is that they're coming down into the slot. And now I'm overfilling the slots because I have not deleted anything yet. So let's, now that is function, that's going to be function of the Plinko slots. It's going to know when the ball has entered the slot, and it's going to remove it. So let's just stop that for right now. I am going to create I'm going to take the disk spawner. I'm going to duplicate it. We're going to just literally remove these components. And I'm going to put the Plinko slot on here. So I'm going to bring this all the way down. Went too far down. All right. So here's my cube. And I'm going to place it right here. And I'm going to adjust the size of the cube. So X is going to be, look up from the top. So I'll do 8. Let's do 6. Not 86. There you go. So 6 will fit perfectly. Just enough. Z, we're going to look at, we'll do like 10 start. Yeah, that'll be good. So we don't have to be perfect. Again, if we look at the slot, the machine, there is basically a cube that is basically the front of the machine. So it won't fall out of the machine. Again, that's why it didn't fall out, because there's that in front of us. So if we push that cube right up to it, which we are right now, we'll be fine. We do need to, now we could have it fall through the trigger. But for my purposes, I'm going to say, I'm going to do Y. I will start with 4. 4 looks good. We can do 3. Do -10. There we go. All right, and we'll rename this Plinko slot. Call it the Plinko slot trigger. Now we are going to go to its box collider. We're going to turn that back on, and we're also going to turn it on as a trigger. So that's pretty much all that we need to do in terms of object setup. We will turn off its mesh renderer though, because it will be invisible. I'm going to leave the mesh renderer on for right now, mostly, and I'm going to put this as slot middle, and I'm going to duplicate this. We'll call this inner. And then down here, I'll put this over here. And then the last copy. And then not call this middle, call this center. All right. So now I've got my triggers set up. I can actually go in now and I can turn off the mesh renderer. So I just wanted to make sure that I had them while setting this up. Okay. We don't need a start. We don't need an update. We do need one variable in play here. Well, 2 variables. Be it public slot score. We'll set that to 100 for right now. And this will be an integer. Sorry, int. The other thing that will be a public float. We'll call this remove delay. We'll set that to like 2.5f. We'll actually call it second, so we don't have to. So that's all that we need right now for what we're doing for variables. The next one that we'll need will be a on. Do that. On trigger enter. And so the first thing we're going to do basically is we're going to do a debug. Debug.log other.gameObject.name. I'll do plus entered, and we'll just, for the sake of argument, gameObject.name. So all we're doing right now is just recording that the balls have entered. What have entered. We'll save this. Bounce over here. Clear that. And then we'll see that. Did I? Oh, I did log warning. My apologies. It's like, why is it all coming in? So, okay. All right. So I'm going to comment this out just because now we know that, trigger is working. So, what I want to do is just to make sure that I'm only dealing with the disks. So the first thing is the other. We have, again, we go to our Plinko application, Plinko disk. So we'll make a variable PD. We'll ask other game object get component of Plinko disk. So just like we have asked for other components, you've seen this. We got the keyboard. We got the keyboard from its current. Again, the next thing will be if PD. I should make this lowercase. Again, this is equivalent to PD is not equal to null. Now we can do this because the components can do this. Unity has written that code to do that for us. This comment right here, don't put that in your code. So another thing that if you put that in your code this week, I will call you out on that. It means you're just copying my code. You're not really understanding the code. And that's the case. Then we're going to do the destroy. Destroy, capital D. And it won't. Now we'll start with PD. That's not correct. But I'm going to show you this to begin with. Okay. All right, so we'll press play. And then you'll see it come through. And here is, you can see that here it is. Let me make another one. So here is the disk script, and as it hits the trigger, it's only removing that script. So remember, so it's removing the reference of the script that we got. This is really going to be pd.gameObject. And let's just start this and restart it. So here you can see that it's taking its sweet time to get down. And it's going to go into there and boom, gone. So the moment it hit the trigger, it went away. Let's add, this is where, let me stop the script. So this is where the move delay seconds. There we go. And that is basically comma, float t. So it's to object what to destroy, float t, the optional amount of time delay before destroying the object. So we set this to default to 2.5. And off we go. And then, as you can see, they're going to hit the bottom and be there. And then after a few seconds, they'll be deleted. And that just there makes this look a lot better. I'll have to check that, if we need to record, like basically, if you were to, before you destroy it, I mean, one of the things you could do is debug.log you scored PDs. Oh, I'm thinking it's on the disk. My apologies. Slot score. Points. So now we can go back. So center, I'll set this to 250. I'll leave and then in the outers, I'll do 50. And you'll see in here, you scored points. Now, we're not tracking those points right now, but this is the first step. Like, you now know, like, hey, we will come back and upgrade this in another lab where we'll start tracking points. So pretty straightforward for what we're doing right now. All right, save the Plinko scene. I'm gonna make a new scene. It will be empty. File, save as. In this case, it's going to be our combat scene. You see, where's soccer? So we're just going to drag the open prefab in here. I'll set that to 0, 0, 0. And that's all that we need. Here we go. Later on, you'll probably want to change this up. Put walls in for gameplay purposes. If you're curious of where we're going, we're basically doing is rebuilding basically the combat for the Atari 2600. So, all right, let's go and combat. And we'll create a new script. We'll call this You'll delete that. Let me just delete you. Will not delete. Yeah, we'll use the rigid body mover. Let's go back. Let me delete this. I got it. Come on. All right, create model behavior script, and I'll call this combat controller for our purposes. I am gonna grab all of this. Not all of it. No, I am going to grab all of it, just for the heck of it. I'm going to go to my combat controller. I'm going to paste it all down right here. Try this more time. All right. First things first. Going to delete everything except that one line of code. I won't need these or copies, and then I'll just repaste this over. So, I'm going to just put in one code. I'm going to do a Boolean right now. Bool fire 1. I'm just going to make a Boolean right now for fire 1. And I'm just going to jump down into my P1. I'm basically going to be, hey, input fire 1. It's going to be the Q key. And it was press this frame. So I'm going to do another. Again, I'm running out of time at the moment, so I just want to make sure I've got. So fire 2. So let's just set this to fire 2. I'm going to worry about player 1 right now. So this will end up being the E key. Later on, you know what? I might as well just jump in. So this is going to be the U key and the O key. All right. So first, so I've got input, getting input on those. I can now, let's see, I'm going to do this right here. Void fire 1. Debug.log fire 1. And I'm just going to put fire 2 in just for the sake of having it right now. Fire 2. So this is going to make our code easy. So after I do our movement code, I'm going to do if input fire 1. And then we'll do input fire 2. And we'll call fire 1. And then fire 2. So we've basically established our first point. So let's jump back into Unity. I'm going to go to, so here in combat, I am going to drag the tank into the scene. So this will be our first player. I am going to break. Yeah, I am going to break the prefab completely. And this will be our tank controller. And then we'll jump back to our combat. We'll apply that here. We do need to add, oh, it has ridge body already. So input player 1, move speed, rotate speed, just so that we know. So we've got that up and going. I'll press play. You see it's rotating and it's moving. Of course, move speed, that's slow, even slow for the tank. We'll do 20 for the heck of it. Now, the code is going to ask you to change your code even more. I might create another video just about that, what's going on and why. But this is okay right now. What we've got is okay. And then if I hit just what's going on? That's weird. I'm getting some errors, but I don't know where they're coming. I have to figure out why these are getting these errors. Something in Unity has gone wrong for some reason. Don't know why, but we'll probably reboot the machine, reload it. Unity will probably be okay. Yeah. Anyways, you can see Fire 1, Fire 2 are activated. So I'm getting my input. All right. Let's go back to Fire 1. And in this case, it's basically going to create a projectile. So first thing that we want to do on our tank controller, add a empty, create empty. And this will be our fire point. Now I talked to you about giving, so you can see this cube right here. If you click on it, you can select the icon. I'm going to pick this red dot. You can see that now I have a game object so in the game view, that's nothing to be seen. I think point 1. And I'm going to move this out a little bit more. Do 2.5. All right, so one of the things I'm concerned about is that, hey, if I spawn a projectile, will it collide with the tank? I mean, that's one of the things I could have gone right in and just take out the capsule collider for that. Now I can move this in, and I don't have to worry about collision with the tank, with the object. Now I can, because I'm in a top-down view, I could cheat. I could have say, hey, do 0.75, and it'll shoot lower. But because I'm in a top-down view, no one's going to know. So there are ways you can cheat. Press play. I probably have to just reboot Unity to clear that out. All right, let's go back to our combat controller. So now that we know that, first thing that we need to do, here's the combat controller. Move speed. What we will need to put in as a new public. I'll use transform to make our life easier. And then public game object. Projectile. So basically, we're going to build. Basically, we're building the weapon right into the script right now. Now that I know that, I can go straight down to Fire 1, and I can be like, hey, instantiate. The projectile free point at the fire point. Now, because fire point is a transform, I can do just fire point dot position. Fire point dot rotation. And again, because that fire point object is parented to the main object, as I rotate around, that rotation will update it respectively. And that means that if I spawn an object rotated, it will keep the heading that I've got. So let's go back to Unity for one moment, and let's create model behavior script. This will be I'm going to call it basic projectile for the sake of argument right now. Won't need an update. I mean, basically, all that we do need is a rigid body RB. We do need I'll say 35. We'll just do 10 for right now. No, we'll go 5 just to be slow. We do want a public float lifetime. It'll be 5 seconds. And do a public float damage value. We'll do 50. We won't actually use the damage value right now, but we will later on. So might as well just throw it in. We'll start with RB is equal to get component the rigid body, and then RB linear velocity is going to be equal to our game object transform dot forward times the move speed. So off we go. The other thing that we can also do right now is destroy the game object at the lifetime. So if for some reason it goes out of the map and it goes off into the distance, 5 seconds later, it will get removed. And that's all that we need to do to set this up right now. We do want to basically have a on trigger enter. We'll use trigger enter for our. Now we could have done collision. I'm going to use trigger enter. If it hits anything at this point, we're just going to do destroy game object. Now we have in the combat. Where is it? Some explosion stuff. So I'm actually going to go use explosion for our sake. I'm going to use explosion red. So let's go back and it will be a the combat. I'll write another script for that. Well, we'll come back later. We'll come back later. I am running out of time in this lecture. So basically, we're shoot objects and then destroy them when they hit stuff. So let's go back to our tank controller. I need to, again, to set this up correctly, I'm just going to create three objects, sphere. Yeah, I'll use a sphere. Where is it? There it is. All right. Where's crayon? I'll just make it red. There we go. I'll stand out. For argument purposes, I'm going to make this like 0.3 and 0.3. So I've got that oblong effect going on. Not going to be too worried about the collision being off. Again, we're just top down, so I'm not going to be too concerned. I will then go back to my combat, give it the basic projectile. And this is going to be my, let's call it projectile number 1. I'll make a prefab of that in here. And we'll just see if when I press play, it will go off and then and it would if I had given it a rigid body. I'm just going to move this up. So you see right here, it's plus signs because I changed to the, what I want to do here is I want to apply to all. So it will apply to this object now. I'll press play, off it goes. And it's going to flop over. So let's go look at this. First of all, didn't make the sphere collider a trigger. Under the rigid body, I should not be using gravity. I should be okay now. It goes off with the wall and poof, off it goes. So just so that we have a better idea of what's going on, go to the projectile, and I'm just going to basically be debug.log dial hit, do other game object, just so that we know what we hit in the scene. And then we've got that. Now I can go to my tank controller and I can say the fire point is here and the projectile is here. I'll press play. And I need to remove that from the scene, but if I hit Q, you can see that. Now, if I hit it fast enough, they are spawning on top of each other and getting destroyed. So that's a function of, hey, this probably needs, I can go in here and change this up. I don't need the rigid body open. So the move speed, we'll do 25. And I can remove this projectile from the scene. The problem is I'm moving faster in my projectile, so I'm running into them, unfortunately. So that is one thing to be concerned about. It is 4:43 right now, so we're running out of time. But this is basically where I'm expecting you to get to with this week's lecture. Your lab work. Get Plutino up and working. Start working on the combat game. We will have more. Your next two labs are basically going to, we're 2-3 labs are going to be building upon this combat game. A lot of work on this combat game. Don't worry about not dealing damages. Don't worry about putting another player in right now. Just get this up and running. Any questions before I stop the recording? Anything you guys want on the recording? Anything I went over too fast you want to see again? No? Okay.